When you walk up a staircase in a public library, a hospital, or a high-rise office, you're interacting with one of the most critically engineered elements in the entire building. This isn't just about getting from floor A to floor B, it's about doing so safely, efficiently. And in a potential emergency, it can be the difference between life and death. The design of public stairs is dictated not by personal taste, but by a complex web of building codes, fire safety engineering, and universal accessibility standards. So, how do architects and engineers choose the right type of stair? In this video, we're climbing beyond the basics to explore the different types of stairs used in public buildings. We'll explain the why behind their design, the strict code requirements for dimensions and materials, and the specialized systems that keep them clear of smoke during a fire. By the end, you'll see every public staircase not just as a structural feature, but as a vital component of the building's life safety system. Let's start with the most fundamental and legally required type, the exit stairway or fire tower. This is the workhorse of emergency egress, as per the International Building Code. These are fully enclosed stairwells with fire-rated walls and self-closing fire doors, typically with a 2R fire resistance rating in taller buildings. Their sole purpose is to provide a protected path of travel from any floor directly to the outside, safe from fire and smoke for a designated period. The materials are non-combustible concrete, steel, and gypsum board. The design is utilitarian, slip-resistant treads, robust handrails on both sides, and emergency lighting. A pro tip from building code consultants is to always verify the required width. For most high-occupancy buildings, exit stairs must be at least 44 inches wide, and their geometry, the relationship between and the riser height and tread depth, is strictly governed by code to prevent tripping during a panicked evacuation. A common and catastrophic drafting mistake is to design a beautiful, winding stair that doesn't meet the minimum tread depth or maximum riser height, forcing a costly redesign during plan review. Now, let's talk about a space-saving genius for high-rises, the scissor stair. This is not a separate type of stair but a configuration of two exit stairways. In a scissor stair, two separate, fire-rated stairwells are stacked one on top of the other in a single, shared fire-rated enclosure. They scissor around each other, so that as you ascend one flight, you land and then cross over to the other stair within the same enclosed shaft. The huge advantage is footprint efficiency. Instead of two separate stair shafts taking up valuable floor space, you have one. However, there's a critical code caveat. Because they share an enclosure, if that single enclosure is compromised by smoke or fire, both means of egress are lost. Therefore, the IBC has strict limitations on where scissor stairs can be used, often requiring additional compensatory safety features like enhanced pressurization. The efficient workflow secret for architects is to use BIM software like Revit to model these complex, interlocking geometries accurately, ensuring code compliance in 3 dimensions. For the highest level of life safety, particularly in skyscrapers and hospitals, we use a smokeproof enclosure. This is an exit stairway on steroids. Its goal is to be impervious to smoke infiltration. It's achieved through one of 2 methods, a mechanically ventilated vestibule or an open-air balcony access. In the mechanical system, you enter the stair through a ventilated lobby that is kept at a higher air pressure than the fire floor, actively pushing smoke away from the stair door. In the balcony system, you exit the building onto an open-air balcony before entering the stair tower, allowing smoke to dissipate outdoors. These are complex, expensive systems but are mandated for the tallest buildings to ensure a tenable environment for both evacuating occupants and entering firefighters. A pro tip for MEP engineers is to meticulously coordinate the ductwork and controls for the stair pressurization fans. A failure here completely negates the purpose of this high-level protection. In contrast to these enclosed, utilitarian stairs, we have the monumental stair. This is the architectural centerpiece, the wow factor in atriums, lobbies, and museums, made from grand materials like stone, glass, and signature steelwork. These stairs are designed to be seen and experienced. They are open, dramatic, and facilitate public movement and gathering. However, from a code perspective, they are a major point of negotiation. An open stair can act like a chimney in a fire, rapidly spreading smoke and heat vertically. Therefore, building codes often do not allow monumental stairs to be counted as part of the required means of egress unless the entire building is protected by an advanced fire suppression system like sprinklers and a dedicated smoke control system for the atrium. A common drafting mistake is for an architect to beautifully render a monumental stair as the primary circulation without consulting the code consultant, leading to a last-minute scramble to add the required enclosed exit stairs elsewhere. Finally, we have specialized types like fire escapes and accessible stairs. External fire escapes are largely grandfathered into older buildings but are rarely permitted in new construction due to maintenance and weather concerns. Accessible stairs are not a separate type but a set of requirements applied to all public stairs. Uniform risers and treads, detectable warnings at the top and bottom, and integrated handrails that extend beyond the top and bottom riser. The principle of universal design means every stair must be safe and usable for as many people as possible. To summarize the key takeaways: 1. Exit stairways are the code-mandated, fire-protected workhorses for emergency escape. 2. Scissor stairs are a space-saving configuration of 2 exits within one shaft. 3. Smokeproof enclosures provide the highest level of protection in very tall or critical buildings. And 4. Monumental stairs are architectural features that require special engineering to be safe and code compliant. Now I want to hear from you in the comments below. What's the most impressive or challenging stair design you've ever encountered in a public building? Was it a complex scissor stair, a breathtaking monumental stair, or a retrofit of an old fire escape? Your experiences enrich our understanding. If this guide to the critical role of stairs in public buildings has been enlightening, please give this video a like and subscribe to Smithage for more content that blends architectural design with life safety engineering.